Hello again everyone, welcome back to ptet.chemistry channel. So this is the new topic, it's called chemical energetics. This is for the combined science or the foundation tier science, which incorporates the three natural sciences into one subject, such that the contents within are not as detailed as the pure chemistry or the pure science curriculum. Anyway, so in this topic, we are going to start off on this idea of exothermic or endothermic reactions. These are just descriptions in terms of what happens in the reactions. Thermic itself, so thermal or the word thermic, it refers to the idea of heat. So these are just English definition: thermal, thermic, thermometer, so something to do with thermoflask, for example. Thermostatic is everything to do with heat. And then we have exo. Exo basically means outside, whereas endo basically means inside. So endo is the opposite of exo. But exo, it's probably quite self-explanatory. If you can understand exo, then you know endo is the opposite. So what does exothermic reaction actually means? Well, in a reaction, you have the system and then you have surrounding. So system is what we cannot see because that is the reactants, that is the reaction, things we cannot see with our eye. But then we are outside and then we are the surrounding. So we can put a thermometer into the surrounding, and our thermometer can tell us, has it gotten warmer? Warmer meaning the temperature is higher, meaning has it gotten hotter or warmer? Or has it gotten colder? But this is what happened outside, and we know that in science, we talk about conservation of energy because, as you know from lower secondary science, energy cannot be created nor destroyed. Instead, energy can just be converted from one form to another. So if your outside gets hotter, it's because the system releases heat to the outside. If your system absorb the heat, if it takes away the energy, then your surrounding will get colder because you lose energy. So we will see a drop in temperature. It means the system takes in the energy. Exothermic or endothermic refer to the reactions. It's not for the surrounding, it refers to the reactions. So basically is what happened with the reaction. So it's got nothing to do with outside, but we can work backward from what happened on the outside to what actually happened on the inside the system. Okay, so candidates should be able to state, you are just needed to state whether what is an exothermic or whether what is an endothermic reaction. So 16.1.1 is similar to 16.1.2 because the first one, exothermic reaction, transfer thermal energy, thermal meaning heat energy, to the surrounding. So you give out heat to the surrounding, you lose energy to the surrounding. So that's basically what it's saying. The system gives out heat to the surrounding. When your system loses energy, where does the energy go to? It goes to the surrounding. So your surrounding must gain the energy. Your surrounding contains particles like oxygen in the air, nitrogen in the air, your water molecules, for example, because you could be doing the reaction in solution that contains water. So your surrounding gain energy. Your surrounding get hotter. Why does your surrounding get hotter? Because your system loses energy. The reaction, which is the system, loses energy, and the energy goes to the surroundings get hotter. You could work backwards. Why does the temperature get hotter? Why does the temperature of the solution increases? Because it gets hotter, because you must gain energy. Where does the energy come from? It comes from the system, from the reaction, losing energy. Why does the reaction lose energy? Because the reaction gives out heat energy or thermal energy to the surrounding. That is basically what they're saying. Exothermic. Exo means give out. Okay, give out. Endo means takes in, absorb. Exo, give out. Exo, outside. Thermic, heat, give out heat energy. Therefore, if your system give out heat energy, your system lose energy, your surrounding gain energy, your surrounding get hotter, therefore your temperature of the surrounding increases. Okay, so everything follows the logic step by step. As I said, the surrounding usually is a solution. In chemistry, we do our reaction in water, and therefore water is our solvent. We get a solution. If the water contain a thermometer dip in it, and the thermometer shows an increase in temperature. That means the water gets warmer. That means the water molecules gain energy. That means the reaction has given out thermal energy to the surrounding. For example, as stated in the syllabus, state neutralization and combustion. There are two separate reactions. They are exothermic. These are technical terms. You must get used to their spelling and cannot spell them incorrectly. Neutralization is between an acid and an alkali or a base. This is stated in the year 9 chemical formula and equation topic. I think I covered that a few months ago, probably a year ago if you are, I don't know, depending on how your teacher teaches you, I guess. But I covered this topic in year 9 with you guys quite recently, at least for my own students. You can check out that chemical equation or chemical formula playlist, all right? So this is your acid and this is your alkali or a base. Remember, an acid contains H plus, and the H plus is the one where the pH is pH is lesser than 7 for the H plus. And you got OH minus, is called hydroxide, and that is the pH higher than 7. And then you will get a salt and you get water. But what is important is neutralization between the acid and alkali is exothermic. What does it mean? It means that it gives out heat energy. It means neutralization gives out heat energy. So they releases or they gives out heat energy to the surrounding. If they do that, that means our solution containing water, because acid and alkali, they are in water, so the water will get hotter, the water will get warmer, the temperature will increase. Similarly, for combustion is when you burn a substance in oxygen. So A contains 21% oxygen, and then you also have 78% nitrogen. Oxygen is diatomic molecule, obviously. Same thing with nitrogen, which is triple covalent bond. That is your year 9 covalent bonding topic in order for each atom to get to a fully filled outer shell, whereas oxygen is a double covalent bond because oxygen is in group 6. It's got 6 of these valence electrons in the outermost shell. Therefore, you just need to share 2 electrons. Therefore, you get a double covalent bond. There's 4 electrons being shared. Nitrogen is in group 5. So group 5 there in your periodic table, 2, 5 for the nitrogen. Therefore, you need to share 3 valence electrons for each nitrogen to go to a fully filled outer shell. Nonetheless, nitrogen is unreactive in the air, so they don't get involved in your combustion. So combustion is exclusively in oxygen. Even when they've mentioned A is only the oxygen in the air that undergoes the combustion. And they will give you carbon dioxide, which is CO2 molecule, as stated in your year 9 syllabus as well. Okay, and of course water is just H2O. And again, that is year 9 curriculum, year 9 syllabus again. Very famous dot and cross. They like to ask you to do that. When you burn something, you can feel the heat, you get hotter. That's because combustion releases heat to the surrounding. Combustion is also an example of an exothermic reaction. Exothermic reaction releases heat energy to the surrounding. Exo, release outside, but thermic refers to heat, so exothermic means release heat energy to the surrounding. This is just a balance equation for what happened with, actually this is not balance equation. It should be 2 O2 molecule, because you got 2 oxygens and 2 oxygen there, so you got 4 oxygen atoms to balance. Therefore, you need 2 O2 there. Make sure equation is balanced, because you could be asked to do reacting masses, a year 9 calculation type of thing. Now the next bit is just finishing up on this idea of endothermic reaction. It's just the opposite. Endo means it's taking in. Endo means inside, and what is taking in? The system or the reaction. The reaction is taking in the heat energy. It takes in or it absorbs heat energy, And where does the heat energy come from? It comes from the outside, from the surrounding. Your system, which is your reactions, if you absorb energy, that means your surrounding must lose energy, and therefore your surrounding will get colder. And when your surrounding outside gets colder, what you see is the thermometer. Your thermometer reads the temperature of the surrounding. To read temperature, you need something called thermometer. I don't think I mentioned it previously, but you also use thermometer in order to read the temperature of the surrounding. Here you use a thermometer. Thermometer is the apparatus. The reading that you get from thermometer is called temperature. Now, your temperature of the surrounding decreases. That means it gets colder because you have lost energy. Where does your energy go to? Your energy gets absorbed by the system of the reaction. And when your system of the reaction absorbs thermal or heat energy from your surrounding, that is called endothermic reaction. Now, as stated in the syllabus, if I go back to the previous page, state endothermic reaction is blah blah blah, as I mentioned, transfer heat energy from the surroundings, leading to a decrease in temperature of the surrounding. You should be able to explain this based on the step-by-step I had just outlined to you. Now, we have dissolving ammonium nitrate. So dissolving ammonium nitrate and cracking are endothermic reaction. So that's something we will go through in detail now. So when you dissolve ammonium nitrate in water, just a brief reminder, this is ammonium ions. It's not ammonia molecule. This is an ion with a +1 charge. And you have nitrate, which is an ion. And these are, as stated in the year 9 chemistry syllabus, these are what we call valency. And valency is based on the charge on the ion. So +1 has a valency of 1, -1 has a valency of 1. So when you do a crisscross of this valency, the one on the right goes to the left, the one on the left goes to the right. This basically tells you how many of these do you have. You have one of these NH4 plus, and you have one of these NO3 minus. How are they going to combine together? They will give you NH4 NO3. This is basically the formula for ammonium nitrate. Okay, so dissolving ammonium nitrate, it makes the solution gets colder because it absorbs the thermal energy. It absorbs the heat from the surrounding, from the water, and therefore the water gets colder. So dissolving ammonium nitrate in water is what you call endothermic reaction. These are technical terms. You cannot spell them incorrectly. So the solid dissolve in water and they become aqueous. In the solid state, the ions are not free to move. Therefore, you cannot conduct electricity. But then when you become aqueous ions, the ions are free to move in the aqueous state. If the ions are free to move in the aqueous state, and therefore you can conduct electricity only when you are in the aqueous or liquid state. Here it's just dissolving in water, so it's not melting. This is what you call dissolving. Dissolving is not melting. Melting is solid to liquid. Ionic compound consisting of cations and anions, positive ion, negative ion, very strong ionic bonds, in order to break. Therefore, very high melting point and also boiling point. But we are going to melt first before we boil. If the melting point is very high, the boiling point is going to be very high as well. Okay. Now the next one is cracking of hydrocarbons. You will learn more of this in year 11. Organic chemistry is the last branch of chemistry that you will learn throughout in this combined science curriculum. But what does it mean? It basically is break up long chain, break up large molecule into smaller chain. 6 carbon become 4 carbon and 2 carbon. You can even break it down to 2 carbon, 2 carbon and 2 carbon. Anyway, so you need to break down big things into small things. You need to break down. The thing is, break down or break up, you need energy. and therefore you need to absorb the heat energy from the outside, from the surrounding, to break up the big molecule into smaller molecule. That's why when you absorb energy from the outside, it's called endothermic. The reaction or the system, this C6H14 needs to absorb energy from the surrounding. You need to supply heat to make sure this reaction happen. Okay, just to recap, exothermic reaction releases heat energy to the outside, to the surroundings. Therefore, we will see using a thermometer that the solution or the surroundings get hotter. When it gets hotter or warmer, the temperature increases. Two examples, neutralization and combustion, are what you call exothermic reaction. On the other hand, you have endothermic reaction. It takes in, it absorbs the heat energy from the surrounding, and therefore the surrounding, which is mainly solutions, it gets colder, it gets cooler, the temperature will drop, the temperature will decrease. Two examples again. One example of which is cracking, and the other one is just dissolving ammonium nitrate. Something you will have done in year 9 is the formula for ammonium nitrate, and you'll come across it when we come across fertilizers and environmental chemistry later on. Alright, that's it really for this short tutorials, and we'll continue more in the next lecture tutorials where we will cover some examples of these exothermic and endothermic type of questions. Don't forget to click the button on the bottom right to subscribe to my channel, and follow me at ptet.chemistry across all the popular social media platforms to get connected. Thank you for watching. See you in the next tutorial video.